So first things first, we're going to show our program compiling using our Makefile. This Makefile right here, we have the port set to 58487. Here's -wall and -w error. We're targeting and creating a file called battle using battle.c and the flags. And here's our clean statement. So I'm going to make, and it compiles with no error, creates the file over here. And I can also make port equals 58472. And if I make clean first and do the exact same thing, it still works with no errors. Okay, to show our client login, we're going to begin with starting the battle server and connecting two people on the server. So connecting one, it says, what is your name? And connecting the second one, it asks, what is your name? No blocking is occurring. On the first one, I'll type in a name. It connects and it says you're awaiting your opponent. And then on the next one, I will type in another name. And as you can see, on the first client, we got a message saying that Joe has entered the arena.
Yeah. So how we've used select to we've used select in our code to monitor all the file descriptors of the clients and see if if there's any input to read from them. Once there is input to read from the clients, then we will go into handle client. And in handle client, what we do is we read input from a client, check and add it to an individualized client buffer. And to set and how we're setting the name of our client is we're checking if the length of the name is less than or equal to 0. That means we're checking if they have a name, if their name is not like an empty car array, or if it's null. Then we'll check where a new line position is, because when we're taking a name, we want to wait for the user to type in enter before to enter in their name before we accept it. So we check where a new if a new line exists, copy the buffer into the name, and then we reset the buffer, reset the number of characters in the buffer, send them a welcome message. Then we broadcast to everyone else in the server that they've entered, and then we try to matchmake for them. In our broadcast to everyone, we check if we go through every single client in the linked list, and we check if they are not the person who is entering the arena, and we check if they have a name assigned, because we don't want things to be announced to people who are joining the server.
Okay, to show matchmaking, we're going to start up our battle server. We're going to connect two clients, one with a name and one with the name Joe. And as you can see, they instantly get matched together, and they can perform their attacks, their power moves, and let's see if we can get one of them to win. Let's see. And there you go. Joe, oh no, this one lost and scurries away, and they don't get automatically matched together because they are each other's last opponent. So I'll join up a new client on the same server with a new name, and you can see name got matched with Joe, who is on a win streak of 1. So these two are now connected, and that is the game working. Okay, to show combat, we will be once again starting our client, connecting two players together, one with a name, one with another name, and they get connected together. There's two moves you can do. Attack, which is a random number from 1 to 3 or 1 to 6, and power move. So on this turn, you can only attack on your own turn. On this player, I can't attack, but on this player, I can. As for power moves, if I press P, I had 1 power move, and now I have 0. And it did an amount of damage, 9. And same for this player. This player has 2. If I press P, now I've got 1. As you can see, this player has 0 power moves now, and it no longer can press P. If I type P, nothing happens. If I press A, it still works. And this player has 1 more power move, so I can press P, and it goes there until combat is finished, where, there we go. Somebody won, this player won, this player lost, and now they are awaiting a new opponent, which there's only 2 players in the server, so there's nobody else for them to battle with currently.
So how combat works is combat is also done in handle client, where we read input and we just dump it into the buffer, and now and if they do have a name, then if the player has a name, it'll skip over that, so it won't set their name again. So in matchmake, we set their availability to 0. So here we check if they're unavailable. That means that they are currently engaged in combat. So earlier we might, if once you might have entered a character, and this is where it would be used. So we read the first character that was sent in our buffer, set it, and then we just run an if-else statement for each of the different moves you can do. Attacking is simple. We use rand to roll a random number from 2 to 6, I think it is. We decrement the enemy's HP, and we send the intel. We inform each player like how much they were damaged for, or how much they damaged someone for. And then we check if the enemy's HP is less than or equal 0. That means they've lost. Afterwards, we end the battle. We try to rematch, make both players again, and we return 0. If the battle is not over, if they survive, then we just print their information, set the read input so that the other player can't start typing input and doing things when it's not their turn. We clear the buffer and we return 0. This is how attack works. Power move works similarly, but we have a check that checks whether we have less than, if we have no power moves left. And of course, power moves have a chance to miss. So what we have here, we use rand to check whether or not. We pick a random number from 1 to 100. If it's less than 50, if it's less than or equal to 50, plus whatever win streak they have, then they'll use a power move. They'll attack them using the power moves values, which is 3 times the normal attack. We'll decrement the enemy's HP and send information. Similarly to a attack, we just check if the enemy was defeated, and change turns. And of course, if you miss the power move, you just decrement power move. You decrement you just say that they missed and print information, change turn order. And then at the end, we clear the buffers so we don't have any like lingering data that we don't want there. Of course, for speak, we just set the speak variable. We send it, asking them to speak, and then we just wait until they start entering data, similarly to how we did it for setting the name.
Okay, to show off speaking, we're once again going to start up our server. We're going to connect 2 opponents together. One with a name, one with another name. That's not what I meant to type, but it's fine. So, the other thing we can do is speak. Not on this one. On your turn, you can speak, and it asks you to speak, and I can type in whatever I want to say. Blah, 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 blah. It's going to send over that message to the other player and only that other player. And it's still going to be your turn. Once again, you can speak and say whatever you want, and it'll keep doing that until you do your message. Now it's the other person's turn. They can speak again, and they can do the same and send over another message. And it continues. On your turn, you can speak. As for the code, it is over here. And what we're doing is we're checking for if they pressed on their turn the letter S. Where is it? If they press the letter S, and we start up our speak function by telling it if they press S, the player is speaking, and we write out our message, and then we turn off the buffer. And in here, we check for if the player is speaking right here, and just like name, there we go. If they are speaking, just like name, we are checking for if there is a new line and who our enemy is. And once we find a new line, we cap it off, we print that message, and then we write it to the enemies, and then we empty the buffer, and we are stopping speaking. So I currently have 2 opponents in our server who have completed a match. If I drop one of them, you'll see that everybody else on the server receives a message that that person left. Let me rejoin and give it another name. And you can see that now it's a new player. They've connected again, and these 2 are connected in a battle. So when somebody else leaves a battle, you can see that you get the same message, but we also, if you're in a battle with that person, it says that they dropped and you won. As for our dropping code, it's right down here. All we're doing is if somebody leaves, we are removing the client. And where's remove client? If somebody leaves, we are removing the client, making sure to get them out of the list and connecting the client list again, making sure that no gaps occur in the list. And if the client that was leaving's availability was 0, we end a battle, meaning they were in a battle, so we have to end that battle. Otherwise, we broadcast that they left, and we free up all of their space. And if they were in a battle, we give their opponent a new opponent. As for the end battle function, right down here, let's find it. End battle, if end battle was 0, which was them leaving, if they left, it does print out that message to the other player saying that they won because the other player left, and it lets them await a new opponent. While also incrementing their win streak, letting the other player be available, making sure that they don't have another opponent, and setting their read input back to 0 so they can't type anything else. To show select working, we're first going to start off by starting up our server and connecting 4 different clients to it, all in iCannon mode. And you can see they're all added. Let's say this is number 1, 2, 3, 4. And as you can see, they are all actively in matches. These 2 are connected and these 2 are connected. And they all got their welcome messages and stuff like that. So I'm just going to attack, power move. And as you can see, they are all mostly, that's a capital, A. They are all engaged in battles simultaneously with no errors occurring.
So how our code works is it uses select. So basically we just select will just basically block until something happens on one of the file descriptors is monitoring. So when a client connects, we add their file descriptor to the list of file descriptors we're monitoring. That way, whenever something happens on one of the clients, we can quickly access the client, do whatever action needs to be taken, and then return to, I guess, waiting for more actions. This means that we don't have to block. We don't have to block reading for like a full input, like waiting for a full input, like a name from like each client. Hence why we can like say have two clients open entering names at the same time. We're just gonna keep waiting for input. Once they're done with their input, we'll just accept it. And yeah, I guess.
Okay, to show our bad behavior, I'm going to connect two clients. That's not a client. I'm going to connect two clients, one with a name, one with another name. And as you can see, they are connected. If one client drops off, they are out of the battle and nothing breaks. As you can see, they are still waiting for another opponent, so I can quickly connect a new opponent with a different name, and they get connected together, and the same thing. Now, if this client drops off, same thing. Nothing is breaking.
So the enhancement that we added is that we'll count each player's winning streak, and depending on the win streak, for each win that a player has, 1% is added to their chance of hitting a power move.
We don't think this is too broken because it's only 1%. And no matter what, even if you hit all of your power moves, it's not that much of an advantage. As for what we all did in the assignment, it was a lot of a group effort with different functions and stuff. Specifically, I worked on the enhancement, and I worked on speak a little bit, and I worked on a handle client and stuff like that.
I worked on getting like building out like the skeleton of a lot of the functions. I also worked on doing the select parts and the rest of handle client.
I worked on doing find opponent and matchmaking, and I also made the whole Makefile.